Assalamu alaikum. Today I am going to present on topic research on enhancement methods for C infrared image using histogram equalization. Let's talk about the content of this presentation. We are gonna start our presentation with research background and significance, and then we shall talk about research status of histogram equalization for image enhancement technology. Then we will discuss about characteristics analysis of infrared image enhancement, and then I shall briefly describe single histogram equalization and double histogram equalization for infrared image enhancement. At the end, we shall talk about summary and future of this topic. Let's move to part 1, which is about research background and significance of the topic. Research background. In the increasingly complex navigation environment, marine distress accidents occur frequently. In order to minimize accident losses, a timely and effective maritime search and rescue work is essential. In the complex marine environment, imaging equipment with infrared detection technology is used to construct a sea surface distress target search system. However, infrared images usually have some non-ideal features such as low contrast, blurry details, and other shortcomings, which will have a serious impact on image observation, feature extraction, and target detection. Therefore, it is necessary to use image enhancement processing technology to improve the contrast of infrared images, especially captured from the sea surface, and also highlight the characteristics of the region of interest, and thereby improve the image quality and visual effect. Now it's time to talk about research significance. The pre-processing technology of image enhancement optimizes the processing and optimization of image degradation problems, thereby improving image quality and providing guarantee for subsequent research on image registration, target detection, positioning, and tracking is essential. The research on infrared sea surface image enhancement is of great significance, and to improve the success rate of search and rescue of sea surface target in distress under complex sea conditions is extremely required. So what are the flow line according to which our research is carried out by sea level infrared images? First of all, we talk about image characteristics analysis, and then we shall talk about image enhancement, then we see image registration, and then we talk about image fusion aspects. Then we move to single frame detection and multiple frame detection and target positioning as well. Then we focus on target tracking and parallel acceleration. Let's talk about research status of histogram equalization image enhancement technology. Histogram equalization is to stretch the image non-linearly and redistribute the image pixel values so that the number of pixels within a certain grayscale range is roughly the same. It is roughly divided into the following two categories. Number one is single histogram equalization, and the second is double histogram equalization. In a single histogram equalization, we take the image and we then compensate the pixel values by focusing on a density function and a cumulative density function, or method of changing the range of pixels stretching on the image. While if we talk about double histogram equalization, so it main focuses on the threshold of the image. First, we divide the image into two sub-images, and then we extract threshold from both of the two images, and then we apply histogram equalization separately on both images, and then we unite them and get the result as our final image. Part 3 is the image enhancement algorithm based on histogram equalization. For this, I'm going to divide the topic into two subgroups. First, I'm going to introduce algorithm for histogram equalization, and then we shall talk about gamma correction. Characteristic analysis of infrared image enhancement. Infrared, for this purpose we should focus on infrared imaging mechanism. As we know that there are two type of images: visible images based highly dependent on visible light, and there are infrared images which do not depend on any light. For visible light, the image we capture from normal cameras, we require light under any circumstance. But in case of infrared images, we don't require light at all. An infrared image is an image formed by using an infrared sensor to receive and record the thermal radiation energy emitted by the same. In nature, when the temperature of a substance is higher than absolute zero, it will continuously emit electromagnetic radiations. This radiation is called infrared radiation. It can be seen from the table below that infrared radiations is generally divided into three segments, namely as near infrared rays having a wavelength range from 0.3 to 3 micrometer. Mid-wave infrared rays having a range from 3 to 8 micrometer, and fair infrared rays having range between 8 to 14 micrometers. There are some grayscale images converted from infrared images. Image A, B, C, D, E, and F. One should keep in mind those images because we are going to go back and forth to tell about the image appearance. As we can see in A image, the pixel distribution is between 70 to 150, which means the image is more darker than bright. Uh, it, this pixel distribution, this clustered pixel distribution tell about how bright or how dark image actually is. Image 2 is slightly brighter than dark because its pixel distribution is more toward higher regions, whereas image 3 and 4 are well bright images than dark images, and image E is more dark and image F is more bright. Let's talk about characteristics analysis of infrared image enhancement. First, we should talk about features of infrared images. In the infrared image system, there will always be a random noise on the image as image is taken by an infrared sensor, and this distortion is caused by lens which is processing images. And then there is thermal radiation attended, which can cause scattering absorption of atmospheric suspended particles on the image, and these unfavorable factors will cause the contrast and definition of infrared image to be lower. The texture details are blurred for the image due to the randomness of infrared photos and photons, not just photo, also photons, and other reasons. A wide range of noises are introduced into the infrared images, such as photon electron fluctuation noise, short noise, thermal noise, etc., resulting in low signal to noise ratio of infrared images. It's time to move to enhancement quality evaluation. There are two methods used for enhancement quality evaluation. Number one is subjective visual evaluation, and second one is objective quality evaluation. Subjective visual evaluation is entirely based on humans. Like if we have a result image, how good this image appears for human, and qualitative or objective quality evaluation is done on the basis of visual evaluation method. In this paper, we talk about information entropy and average gradients to evaluate the enhanced image. Let's talk about single histogram equalization for infrared image enhancement. In this part of single histogram equalization, I'm going to introduce the principle of classical histogram equalization and gamma correction. My modification and experimental results are also included in this part. Let's talk about histogram equalization. As we have discussed earlier, that histogram equalization is a technique for adjusting image intensities to enhance or contrast the visual appearance of the image. In other words, we distribute the clustered pixels and distribute them evenly throughout the axis, both on x-axis and y-axis, with this uniformity that image almost have the same distribution along y-axis. While as we can see the images on real image, the pixels are somewhere it's are distributed high, and at some parts they are very low. So for histogram equalization, there is RK and NK. RK stand for kth gray value of the image, and NK total gray values, gray pixels of the image. First, we calculate the probability of the image by using this equation over here, and then we find a cumulative density using this equation over here, and then we use a mapping, then we create a mapping process where SK replaced this RK. Gamma correction. Let's talk about gamma correction in this slide. So what is gamma correction? Actually, gamma correction is a function that maps a luminous level of and compensate the non-linear luminous effect of display devices, for example. So what do I mean by this? For example, these are three images with three different gamma correction. This one has a gamma correction with value less than 1. This one is equal to 1, and this has a gamma value of mapping or gamma value more than 1. Now what does this mean? It means that we are going to distribute our pixel ratios more linearly. Like in this case, gamma value is equal to 1. If this was this case or this case, we are going to get like this structure, and in this case we are going to get this more dark image and more bright image. So what do gamma correction do? Gamma correction actually uniform the image. It uniform the image distribution. Uniform the pixels inside the image, or uniformly distribute the pixel of the image. Here we can see that there are an experimental analysis of my work, where these are the raw images, and these are simple histogram equalized images based on built-in function, not a function I derived, but built-in function. And here is a result from my enhanced or my introduced method, and at the end we are having gamma correction. We can see if we just apply histogram equalization, standard histogram equalization, these are still blur, and these as well. But if we apply my method or my proposed procedure, these are a bit prominent, and so are these. But if we do but if we initially or additionally apply gamma correction, like histogram equalization, my introduced method plus gamma correction, we are going to get more uniform, more clear picture. And here we have the chart to display our results. Like in dry image, number of information and spatial frequency has these values. Like for group 1, the first 3 images, and group 2 and second 3 images, which is a little bit downwards by applying histogram equalization plus gamma correction. And if we talk about a spatial frequency, it is enhanced. Let's talk about double histogram equalization for infrared image enhancement. First, let's talk about what is double histogram equalization. On double histogram equalization, we divide one image into its two sub-images based on the mean of the image. What do I mean? First, we calculate the average gray value of the image. For example, we had an image, we calculate the average gray value. And then we convert this image into two sub-images, one with the values higher than the average and other having gray level values lower than the image. There are two images, image U and image L, with these pixel ratios. and then we apply histograms on these images by calculating probability for both images using this formula, and then we calculate cumulative probability of the images by applying this formula, and then the corresponding relation m between the gray value before and after equalization by applying this value, and then we create a double histogram equalization graph of the final image, and that's the end of our work. Double histogram equalization of infrared image enhancement. Characteristics of infrared images and advantages of double histogram equalization are discussed in this slide. As we can see that from this image, we can see that image has very low contrast, unclear texture detail, and uneven brightness. If we see this image, on the other hand, we have more clear visual appearance, more clear edges of the objects inside the image. So double histogram equalization is more advanced and better technique to enhance sea level infrared images. Okay, it's time to talk about threshold selection. There are three scenarios to select threshold, depending on the mean of the image, depending upon the median of the image, and depending upon the average of mean and median. Like if we use mean to calculate double histogram equalized image, this is the final result. If on the base of median we get this, and by applying x1 not equal to but greater than dx2, like we have one image with two gray level distribution, one higher than the mean and the other lower than the mean, which is this case, then we get this result. Here are some clear and visual explanation of our images. So we can see this is our original image in this row, and if we apply on them single histogram equalization and gamma correction, we get this result. Shape is more bright, objects are bit more bright, objects are a little bit visual, and there are objects more bright but we can see them. But if we apply a dual histogram equalization by using dual threshold value, we can see that now objects are more prominent than here, and as we can see here and here as well. So what is EN and SF values of applying single histogram equalization with gamma correction and double histogram equalization with depending upon the threshold? Here I would like to tell you that EN or number information is highly associated with the brightness of the image. Greater this value means image is more clear, while lower this value means image is more darker, or the appearance is not as good as we want them to be. Here we can see that image A, by applying single histogram equalization, one EN value of 4.94, B image 5.2, C 5.6, D this value. But after applying double histogram equalization, which more enhance the image and more enhance the image information, we get these values, which are in every case more than this. Same case with a special frequency value, we get these values, more and more bright. Summary and outlook. Based on analysis of the characteristics of the infrared image, we try to enhance the stretching range of histogram and select different gamma correction and parameters for realizing. Especially we compare the experimental results of the original image, the classical single histogram equalization, the single histogram equalization with changing the stretching range, and the gamma correction method with different parameter selections. And it can be seen that gamma correction with different parameter selections go on different result on the final image, whereas the main topic double histogram equalization gives the best result out there. So we create a larger dynamic range of the stretched gray level values, and therefore brightness of the image was unexpectedly increased. The dark images become more brighter, and brighter images brightness was preserved. They were uniform at the end. Future work prospects of this work. After a series of research work mentioned above, the infrared image contrast of the target seen on the sea surface is significantly improved by applying our double histogram equalization method. Histogram equalization is the best and most reliable Asian technique that has been used to enhance the contrast of the images. Or and if someone wants to use R derived or R applied algorithm for other scenes than a C scenario, they have to adjust parameters a little bit. Thank you so very much. I will appreciate if there is any question.